Alright, in this video we're going to look at optimization. And what optimization basically is using derivatives to solve word problems, basically. So let's look at a word problem. We have a word problem here saying that we want to make a fence of 100 yards to enclose sheep. Well, you could say cows or bulls, whatever floats your boat. So let's build a fence along the side of a barn to save some materials. Okay, so if we do build this fence on the side of a barn, how big do the sides need to be to maximize the area? And the most important things you have to keep in mind is maximizing the area. So let's draw a picture to get a better idea of what we're talking about here. Say we have a barn. We're going to go ahead and label it so we don't get confused. And we're going to build a fence along the side of it. And we're going to label each side. We're going to label this side X, since they're both the same side, and this side Y. Now, we know that the area formula, since we're trying to find area, is X times Y, or length times width, of course. But since we're using X and Y, I apologize. X is going to be width, and Y is going to be length. But it doesn't matter. Eventually, it'll come back to the same answer. So we're going to use X and Y. Let's go ahead and write down the formula 100 yards, and we have two X's and a Y. So we have this function to work with. 100 equals 2x plus y, since we have 100 yards of fence. Now we're going to go ahead and solve for y and get y by itself. It's much easier than getting x by itself. So we have y equals 100 minus 2x. Now this is going to be important. Keep this in mind. We're going to go back to the area formula right quick. We have area equals x times y. Well, we said we're going to just keep x, but we know that y is 100 minus 2x. Remember, we use that there to solve for y. Excuse me, we use that there to explain what y is. Now we're going to go ahead and distribute and solve for this. So area here equals 100x minus 2x squared. Now, of course, we're going to have to take the derivative of this. So a prime. So this will be 100, since the derivative of 100x is 100, minus 4x, the derivative of 2x squared. Now we're going to set this equal to 0 because we need the critical values, because we need x, and x is one of the sides of the fence. So we're going to set this equal to 0, and we know eventually that x is 25. So we have our x. Now what we're going to do is use this and find out what y equals. And to do that, we're going to plug it back into this equation. So what we have basically is y equals 100 minus 2x. And we know that x is 25 because we found out the critical value. So let's go ahead and erase this times 25. And we find out that y equals 50. So we have our two main values here, x and y. And that's basically what we need to find area, because we're looking for area, maximized area. So we have area equals 25, which is our x, times y, which is 50, and we get that area equals 1,250 yards squared. Since it's area, we have to use square. So let's go back to the picture. We know that x is 25, and we know that y is 50. And of course, these are all yards. And we know that area, after you multiply x and y, is 1,250 yards squared. And that is how we do an optimization problem.